Hi, I'm Isha, and this is my Intro to Data Science final project on Spotify's top 200 charts. So this data set includes songs that have been on the top 200 weekly global charts of Spotify from January 2020 to July 2021. It has 1,556 songs and 22 variables. I chose this data set because I wanted to explore what makes a song popular, and I wanted to see if you could predict the number of streams a song would get based on attributes of the song. So the variables include the highest charting position, which is the highest position the song was ever at on the charts, number of times charted, which is the number of times or number of weeks that the song was on the charts, week of highest charting, which is actual dates of the week during which the song was charted the highest, the song name, the song ID, which is an ID that is unique to each song provided by Spotify, streams, artist, which include any featuring artists on the song, artist followers, so the number of followers this artist has on Spotify, genre, which includes every single genre that the song falls under, release date, which is the date that the song was first released, weeks charted, which are the actual dates of the weeks that the song was on the charts. And now in the right column, we have variables that are attributes of the songs, including popularity, which is the popularity of the song, danceability, which describes how suitable a song is for dancing based on a combination of musical elements, acousticness, which is a measure of if the song is acoustic, energy, which represents a perceptual measure of intensity and activity, liveness, which detects the presence of an audience in the recording, loudness, the volume of the song in decibels, speechiness, which detects the presence of spoken words in a track, tempo, the speed of the track in beats per minute, valence, which is a measure describing the musical positiveness conveyed by a track, duration, which is the length of the song in milliseconds, and chord, which is the main chord of the song instrumental. So now on to data preparation and summary. I began data cleaning by removing columns that I would not need. So I removed the index, which was a column that just had the row number of each row, song ID because I would not be using it, and week of highest charting and weeks charted because I would not be using the actual dates of those weeks. So then I began renaming the columns. I normally reworded column names to make them more understandable or shorter and standardized all the names by using underscores where spaces would be. I then made all of the column names lowercase so that they would all be in the same case. For mutating columns, I changed the streams column to the numerical variable type because it was given as a categorical variable. I calculated the song's duration in seconds because song duration is normally spoken about using seconds. I calculated the song streams in millions so that I could use that information for the graphs and regression models. So for summarizing the variables, first I researched what the top 10 most popular genres were and used those to categorize the genres. Since many songs fell into multiple genres, I went in order of the most to least popular genre when categorizing, with the exception of K-pop, because the K-pop songs would fall into pop if I categorized by pop first. So the genres I had were K-pop, pop, hip-hop, Latin, rap, rock, dance, alternative, indie, and country. So all of the songs that didn't fall into those categories went into the other genre, which includes songs that had NA, a blank string, or a genre that just didn't fit into the other genres. So next, I wanted to categorize songs as pop or not pop to use for my logistic regression. And again, I had to categorize by K-pop before pop to make sure that K-pop did not fall into normal pop. And lastly, I rearranged the columns of the data frame in an order that made more sense to me. So these are the summary measures, and first are the categorical variable tables. And this first one is a table of the genres. So looking at this table, we can see that there were no songs categorized as alternative, as they might have had another genre that took precedence and got categorized under instead. Also, the one song in the dance genre is probably because many songs had the genre of dance pop, so those would have gotten categorized as pop instead of dance. Most songs fell into the pop category, which is understandable since pop is just a shortening of popular. So naturally, there would be many pop songs on the top 200 charts. There were 10 country songs, 1 dance song, 218 hip hop songs, 2 indie songs, 52 K-pop songs, 119 Latin songs, 185 other songs, 767 pop songs, 171 rap songs, and 31 rock songs. So next we have a table of the chords, and the blank category is the songs that had a blank string as the chord, and therefore the chord information is just missing from that song. So all of the chords with slashes are chords which could have been written differently but are musically the same, such as A sharp and B flat. So there were 11 no chord listed songs, 118 A chord songs, 122 A sharp B flat songs, 141 B chord songs, 155 C chord songs, 214 C sharp D flat chord songs, 112 E chord songs, 131 F chord songs, 121 F sharp G flat chord songs, 136 G chord songs, and 130 G sharp A flat chord songs. So here we have summaries of song statistics, and the first summary is of the number of streams in millions. So there's a minimum of 4.2 million streams and a maximum of 48.6 million streams, with a median of 5.3 million streams and a mean of 6.3 million streams. And it looks like the maximum number of streams was really an outlier, as it fell really far away from the median. And it looks like most of the songs had only less than 10 million streams. So next is a summary of the highest charting position of each song. There is a minimum of 1, which is the highest position on the chart, and a maximum of 200, which is the lowest position on the charts. And there was a median position of 80 and a mean position of 88. So it looks like most songs charted on the lower end of the charts and were not able to reach a higher position. So the last summary here is the number of times a song is charted. There is a minimum of 1 week on the charts and a maximum of 142 weeks on the charts, which is over 2.5 years on the charts, which is a very long time. And that song is Falling by Harry Styles. And there is also a median of 4 weeks on the charts and a mean of 11 weeks on the charts. So it looks like most songs were on the charts for a short time of about 1 to 3 months. So these are summaries of the song features, and it looks like there were 11 songs that did not have data for any of these, as shown by the NA column on the right of all of these tables. And so the first is a summary of song popularity, with 0 being the least popular and 100 being the most popular. There was a minimum of 0 popularity, which is either a mistake in the data, or it is very interesting that a song could be on the top 200 global charts, but somehow have 0 popularity. And there was a maximum of 100 popularity, a median of 73, and a mean of 70. It looks like most songs were on the popular end, and it would make sense for more popular songs to be making it onto the charts. Next is a summary of danceability, with 0 being the least danceable and 1 being the most danceable. The minimum was 0.15 and the maximum was 0.98, with a median of 0.71 and a mean of 0.69. So it looks like most songs on the charts were very danceable. And last is a summary of energy, with 0 being the least energy and 1 being the most energy. And the minimum was 0.054 and the maximum was 0.97, with a median of 0.64 and a mean of 0.63. So it looks like most of the songs on the charts had a fairly high level of energy. So now we have data visualization. And for the visualization of key variables, this is a word cloud of artists, where the size of the artist represents the count, which is the number of songs that that artist had on the charts, and the color represents the genre of artist. And we can see a lot of blue, which represents pop artists, and purple, which represents rap, and orange, which represents hip hop. So the artists that had the most songs on the charts were Bad Bunny, Pop Smoke, BTS, Justin Bieber, Juice WRLD, Lil Uzi Vert, with Taylor Swift being the largest, as she had 52 songs on the charts within the time period of this data set. So this next one is a bar graph of the genres. So in order from most to least songs, there is pop, hip hop, other, rap, Latin, K-pop, rock, country, indie, and dance. It looks like pop accounts for about half of the songs on the charts, which makes sense since pop is just popular songs. So this is a histogram of highest charting position. And here it looks like there are more that chart higher than 100. So a number that's less than 100, than below 100, which is a number that is greater than 100, which is interesting considering that the summary of the data told us the opposite. So for two variable visualizations, this is a side-by-side box plot of chords and danceability, with chord on the horizontal axis and danceability on the vertical axis. It looks like the chord doesn't really affect the danceability of a song, with the B chord and G sharp A flat chord being slightly more danceable than the rest of the chords, but they're on a fairly similar level. So this is a scatter plot of popularity and number of weeks on the charts, with popularity on the horizontal axis and number of weeks on the charts on the vertical axis. And so generally, the more popular a song, the longer it spends on the charts. But I found it really interesting that the songs with the highest popularity around this area on the graph spent a fairly low number of weeks on the charts as compared to this area of the graph, where the popularity value is 75 to about 88. And at this point here at the top is Falling by Harry Styles, which does not have the highest popularity, but does have the longest time on the charts. So for three variable visualization, this is a bubble plot of energy, danceability, and streams, with energy on the horizontal axis, danceability on the vertical axis, and streams in millions as the size of the bubble. It looks like most songs that charted tend to have a fairly high energy and a fairly high danceability. However, it doesn't look like there is any correlation between danceability and energy and the number of streams, because the bigger bubbles here, which are here, 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 around there, which represent a larger number of streams, are all around the upper right-hand corner of the graph. And although there isn't a specific trend, it does look like songs that are high in energy and danceability tend to get more streams. For the special graph, this is a heat map of chord, genre, and danceability, with chord on the horizontal axis, genre on the vertical axis, and danceability represented by the color of the tiles. And the gray tiles mean that there was no song that had that chord and genre combination, and therefore that area is just blank. So it looks like the combinations that have the most danceability are rap with a G sharp A flat chord, pop with an A sharp B flat chord, and hip hop with an A sharp and B flat chord. The combinations that are the least danceable seem to be rock with a C chord, other with an A sharp B flat chord, and indie with an A chord. It is quite interesting that the A sharp B flat chord has some of the most and least danceable songs. It also looks like the genres with the most danceability are hip hop and pop, and the least danceability is country. So now on to the 1 and 2 sample inference. So for the 1 sample inference, the population of interest is all the songs that have been on the top 200 weekly global charts of Spotify from January 2020 to July 2021. And the parameter of interest is the proportion of pop songs of all songs that have been on the top 200 weekly global charts of Spotify. So by completing a 1 sample proportions test, I found that we can be 95% confident that 49% of all songs that have been on the top 200 weekly global charts of Spotify are pop songs. And so for the 2 sample inference, I wanted to compare the mean streams of pop songs and the mean streams of hip hop and rap songs for all songs of those genres that have been on the top 200 weekly global Spotify charts. So since there were many more songs under the pop genre, and that often hip hop and rap are considered part of the same genre, I decided to add the hip hop and rap songs together to do this inference. So by completing a 2 sample t-test, I found that we can be 95% confident that the mean streams of all pop songs that have been on the top 200 weekly global charts of Spotify is 6.5 million, and the mean streams of all hip hop and rap songs that have been on the top 200 weekly global charts of Spotify is 6.2 million. So it looks like there isn't a very large difference between the mean number of streams of pop and hip hop and rap songs. On to the regression models. So for the multiple regression model, I wanted to create a model to predict the number of streams for a song. I used almost all of the numerical variables in my model, including the number of streams, artist followers, highest charting position, number of times the song charted, duration of the song, popularity, danceability, energy, loudness, speechiness, acousticness, liveness, tempo, and valence. So when I put my model into the step AIC function, the function decided that the most important variables were highest charting position, number of times charted, popularity, danceability, loudness, speechiness, liveness, tempo, and valence. So this model shows that when the highest charting position, number of weeks charted, danceability, loudness, or speechiness decrease, but the other variables remain constant, the number of streams increase. This model also shows that when popularity, liveness, tempo, or valence increase, but the other variables remain constant, the number of streams increase. So to predict the streams of a song, I tried to create a song that I thought would have a large number of streams. So I used a highest charting position of 1, a value of 52 times charted, which is a year, 95 popularity, 0.8 danceability, -5 loudness, 0.05 speechiness, 0.03 liveness, 150 beats per minute as the tempo, and a valence of 0.7. So this model predicted that this song would have 7 million streams, with a lower end of 900,000 streams and an upper end of 13 million streams. So this is higher than the mean and median number of streams, but it could be higher. So for the logistic regression model, I wanted to create a model to predict the probability of a song being a pop song. So I used the same variables that I used in the multiple regression model and added a pop column that had 1 if the song was a pop song and 0 if the song was not a pop song. So when I put my model into the step AIC function, the function decided that the most important variables were artist followers, highest charting position, number of times charted, popularity, danceability, energy, loudness, and speechiness. So this model shows that as the danceability, energy, or speechiness increase, the probability of the song being a pop song decreases. And it also shows that as the artist followers, highest charting position, number of times charted, popularity, or loudness increase, the probability of the song being a pop song increases. So to predict the probability of a pop song, I tried to create a song that I thought would be a pop song. So I used 5 million artist followers, a highest charting position of 1, 26 weeks charted, 95 popularity, 0.8 danceability, 0.7 energy, -5 loudness, and 0.05 speechiness. And the model predicted that this song has a 61% chance of being a pop song. And these are my references.